I'm Nate. Tarbox, as Clayton just introduced me. I'm sorry. It's nice to see a lot of familiar faces in here. I will say I'm intimidated with the sense that there are a lot of presenters that are much smarter than I am and more gifted than I am coming up right behind me. So I'll try to make my part of this thing brief. The Maryland Bioenergy Center, was constructed here about 2 years ago, and Bay Ready Mix was fortunate enough to play a small role in that. What it is a food digester. So not only was it renewable in what they were trying to do when they built it, its entire mission is basically to use waste product and turn it into natural gas and soils and things along those particular lines. So it really does encompass everything about sustainability. Our building partners in this, the owner is a company called BTS Biogas, and they are actually out of Europe, and I'm drawing a blank on the country. You can see the other partners, the guidance, the general contractor was Stewart and Tate. The concrete contractor for the ready-mix side was M2, but the precast tanks was done by Dutchland Inc. We were the ready-mix supplier for the concrete in the building, all the areas around those tanks. And then Cheney Enterprises actually was a partner in this project, supplying the concrete to Dutchland to put those tanks together. In this particular part, looking at the ready-mix concrete side of the equation, in our particular specification, they require a type 2 cement. So what they're doing is they're taking waste food product and they're collecting it, and then they're basically allowing the organics to do some sort of chemistry that it does, and that creates a lot of mysterious agents that can go after concrete, steel, any of those particular number of things. So in this particular setup, they asked for a type 2 cement. They did not want any components in the ready-mix side of the equation. It was kind of a counterbalance. We're not quite exactly sure, because on the tanks, they actually use slag and fly ash using those. So coming at it from our vantage point, what we did is to reduce the total amount of cementitious needed. We used carbon mineralization technology. We actually used carbon filters. So we were injecting carbon dioxide gas. From 2 phases of that, what we were allowed to do is we were capturing the carbon dioxide that we were actually injecting. The other thing that we were doing is we were also minimizing what I call the insurance cement. Right? We achieve our over design when we do a mix design and we submit it. And we're doing our F5 sub C, at 5,000 PSI or 4,000 PSI. And then sometimes in a project like this, when you have strip strain, things like that, you start bumping that up a little bit. If anyone in here who does mix design submittals for a producer kind of knows where I am on that. Like there's a certain level where you're comfortable at. What the carbon cure that we were doing is that gave us a bump of about anywhere from 2 to 5% in strength. So what that did is that allowed us to just kind of go to that FRC number and be comfortable with that, right? And that's where we were instead of having what I call insurance. Going on to the, I'm talking way too fast, so you guys are having a lot of extra time. Going to the precast tanks, Dutchland came in and they poured a foundation for these particular tanks. And then what they did is they precast the walls, and they set the walls into place. In those walls being set into place, they then filled that with a special concrete mixer. It was almost like self-consolidated concrete that went in between them. And then came back and post-tensioned that. There is a gentleman from Dutchland here today, so if you have questions at the end of how they did the post-tensioning, I'll ask you I'll have him answer those questions for you. Well, what they were able to do is pull these tanks together, and those tanks are containing, again, liquids that are coming off of this food that is coming back, mostly a vegetable-based food that they're messing around with. As you can see, the tanks inside are feeding into a whole other process where we have the raw food coming in and everything else. What we were able to do on the carbon savings with this particular setup is save about, with just the injecting the carbon dioxide on the ready-mix concrete side, we were able to basically create 81 acres of trees absorbing CO2 for a year. Not an insignificant amount. That comes from that cement that we saved, which was a huge amount. It was not that much when you actually look at what you could possibly do. And that is equivalent to 150,000 miles of driving a car, so basically like one average mileage in 1 year. What the Bioenergy Center does is even more remarkable. It's recycling 110,000 tons of food. So it's taking 110,000 tons of food waste, stuff that would go into landfills, biodegrade, things along those lines. Right? They're taking that, they're putting this into the structure, and they are putting out 312,000 MMBtus of natural gas with this thing. That is an incredible number to pull out of something that would have just sat and done absolutely nothing beforehand. And the other thing is, the side market, is they're doing that. They actually, per year, are making 16,000 tons of actual soil, topsoil that can be used by farmers and things along those lines. So when you look at kind of how this particular project goes, it's providing energy, but it's also providing other stuff for environmental and other uses that help our food supplies and things along those lines. That's all I got. So,
thank you, Nate. Anyone questions for Nate or for the Dutchland?
thank you.
All right. Thank you.